So the first step in differential equations is learning how to solve equations using the integrating factor. And the integrating factor is used to solve differential equations of the form y prime plus a function of x times y is equal to another function of x. And we solve this by multiplying the entire equation by the integrating factor. And the integrating factor is supposed to make it so we get an equation of the form y times another function of x, let's call it g of x, and the derivative of all of that is equal to some function of x, let's call that I of x, it doesn't really matter. And we want this form because then we can integrate both sides and we'll have y, and we can just divide everything by g of x, and we'll have our explicitly defined y of x. So let's try solving for that. So we're going to multiply everything by g of x. So g of x times y prime plus f of x, it's supposed to be an f, sorry, y, it's supposed to be multiplied by y, is equal to, well, it's just going to equal to this, our end result. It's going to equal to y g of x prime. So let's multiply this out, and let's multiply this out. So we're going to get g of x y prime plus g of x f of x y is equal to y prime g of x plus y g prime of x. And we'll immediately see that this term and this term cancel out. So then we're left with g of x f of x y is equal to y times g prime of x. Well, we're not going to look for the trivial solution, so we can cross out the y's. So now we're left with g of x f of x is equal to g prime of x. So let's divide everything by g of x. So f of x is equal to g prime of x over g of x. And so let's set up a u substitution because we can just integrate both sides. Well, let's first multiply both sides by dx, that's dx, and we'll indefinitely integrate both sides, and we'll set up our u substitution. So we're going to integrate this, so what should our u be equal to? Our u will be equal to g of x, and our du will be equal to g prime of x dx. So u is equal to g of x, du is equal to g prime of x dx. So we'll immediately see integral of f of x dx is equal to, so if we make the u substitution, then we'll get just 1 over u du, which is the integral of that will be natural log of absolute value of u. And so then if we back substitute, we'll get natural log absolute value of g of x plus c. But we're going to find out that since we're going to be multiplying the entire equation anyway later on by the integrating factor, that we won't really need to care about the plus c. So let's exponentiate all of this, so then we can finally solve for g of x, and we finally find that g of x is equal to e to the integral f of x dx. So if we multiply this entire equation up here, y prime plus a function of x times y is equal to h of x, by e to the integral of our f of x dx, then we'll find that we can write it in the form of our product rule, y times g of x prime. And then we can just integrate both sides since that's a derivative, and we can just integrate that function explicitly since it's a function of x, and we'll be able to solve for y, and we'll do an example in the next video.